Okay, I'm going to go ahead and cover how to use the grapher in my math lab to graph what usually is a key graph that we're already familiar with, and then a function that represents a transformation of the graph of the previous function. So first of all, I wanted to show you that so I can switch over here. In the opening screen, the homepage for my math lab, I have posted this sheet that's a summary of the transformation graphs, and I also emailed it out to everybody as an attachment, so hopefully you can look at that. But if you look at this, I'm hoping it shows up. It's much easier to take that x, whatever it was, x cubed, what is it, x cubed. All right, I'm trying to get the thing to move off the top of the screen. Minus a, x cubed minus a. All right, it's much easier to visualize x cubed minus a. If we go back to this picture, I just go through all the different kinds of transformations on this sheet. It's just kind of a summary. Wherever you see the f of x when you're reading through this, think of f of x as x cubed, x squared, whatever the version of one of those key graphs that you've studied previously, absolute value, cube root, all those key graphs. If we just visualize what those look like, and then we just mentally slide them around left, right, up, or down, that's a lot more fast to graph that than it is to graph a bunch of points. So what we have on that problem, it said -8, I think. So f of x minus 8, what does that say? Vertical shift down of the graph of f of x by k units. Okay, so anytime you have a number that's added or subtracted to what would be one of your key graphs, that has the effect of taking that original key graph and sliding it or shifting it up or down by this number of units. Okay, so let's go back to that homework assignment, that homework problem, which is here. And if it says x cubed and x cubed minus 8, we're going to graph them both together. So when we go to hit the grapher, you have to first just put down the key graph, which is x cubed. When you roll over it, it will pop up and say, there's the x cubed tool, and then it follow the instructions. So just click the graph to plot your curve. I think when you start, you can click it anywhere and it will lay in that x cubed standard graph. And in a key graph like this, the vertical stretch or compression, that's like that. That would be having to do if there was a multiplier in front of the x cubed, which there's not. The vertical shift that we saw has to do with this box right here, but those always have to do with whether something's added or subtracted. And we know that plain old x cubed has no extra numbers in it, so we're just going to clear that and save that as our first graph. So that is the graph of x cubed, which is our key graph. The one we're trying to visualize is x cubed minus a. Now I know when you do the click an example and view all the steps, they have you plotting a bunch of points, which would be taking different x values, cubing them, and then subtracting 8, and then trying to get the graph of that along there. I think it's easier to go from that summary sheet and say, all right, x cubed minus 8 is really just the graph of x cubed, where every point has been vertically shifted down 8 units. So if I look over here at this graph, normally the key graph kind of has that flattened area in the middle. It's passing through the origin, passes through the y-axis and x-axis at 0. If it's x cubed minus 8, every one of these points is going to have a 8 subtracted from its y value. So everything, including this flattened out piece, is going to lower by 8 units. So we're going to see this graph just drop down here and cross through the y-axis at -8. So what I'm going to do, I have to graph that. So I'm going to click another graph of the cubic, and it's going to start in the same position, but now I need to tell it lower it by 8 units. So vertical shift is really just whatever the number is after that x term. So I'm going to take that out and write -8. That means it's going to drop 8 units. And watch what happens when I close the window. Okay, do you see that the second graph that hasn't been saved yet has been lowered? So the blue graph is the one that we saved, that is x cubed. The yellow graph, once I go ahead and, whoops, I didn't mean to do that. Once I save it, it's going to be the x cubed minus 8 graph. Check it. So then it asks us, well, what happened there? And that's what I want to start with. I want to start with knowing this first. Well, the correct transformation was when we say something was dropped or lowered, we say that's a vertical shift down. So 8 units down. Okay, so we can continue to do these. If we look at the next one, this one has a number on the end here, -2, like the -8 from the previous problem, but it also has a number being added or subtracted to the x as the very first step. So there's a couple of places where you can add or subtract numbers, and depending on where you're adding or subtracting, it has a different effect of moving the graph in a certain direction. So we've studied this one already. The one that is a term by itself is going to take the old key graph and drop everything 2 units down. In this case, notice that the part that's not added or subtracted, that exponent, it's squared this time instead of cubed like it was on the previous one. So the x squared gives us an idea of what shape we're working with. This one's working with some kind of a parabola that's been dropped 2 units from the standard position. And then this is another idea that's in the summary sheet. If you add or subtract a number to the x right here as a first step, and usually you'll see it because there's parentheses or absolute values wrapped around it. So the number that's right next to the x. So it's the first number that you would add or subtract when you're doing the calculation. That has the effect of moving it sideways. Since x is a horizontal control, if you add or subtract numbers to the original x values, it has the effect of moving them around. And I don't want to spend a lot of time explaining it because it takes a long time to explain why this is the case, but it seems counterintuitive. If it says x -5, that actually is going to shift the original point right by 5. Has to do with what x would have to be to make the whole thing turn back into 0. X would have to be +1. So whatever the 0 is, remember we talked about that, whatever x has to be to make this 0, that would be the shift. So it's going to have to go 5 units to the right. So this is going to take x squared and it's going to shift it 5 units to the right because the number with the x is 5 and a -5 shifts right. +5 would have shifted left. And then the -2 at the end is a less complicated vertical shift and it will shift down by 2 units. So I'm looking for something here that says horizontal shift to the right by 5, down by 2. Let's say A, right to the 5 units to the right, 2 units down. Well, that's it, the very first one right there. All the other ones are off by 1 or the other is going the wrong way. Okay, so if it's x minus a number, it shifts right. If it's a minus number at the end, that shifts down. So that's the vertical and horizontal shifts kind of real quickly. Look through that document to talk to you about other things like how to flip it upside down or how to make it more skinny or more flattened out than the standard shape. But the shifting things left, right, up, and down is all about adding or subtracting numbers either right at the beginning next to the x, it's a horizontal shift, or adding or subtracting a number at the very end, which is a vertical shift. Okay, so I hope that is enough to get you through 4.1 or most of those, and I'll send this out shortly.